Hello. Hello.
Yeah, so this is the second Facebook React user group meeting. It's your group, not our group, and we desperately need speakers and stuff. Like I'm going to talk today, and I don't really want to talk last time. I hate talking. Yeah, if anybody wants to do any talks or get involved, please do. It looks like at some point we're going to need somewhere else to do it because we do have upstairs as well, and that might work. In September we're going to have a month off next month, so we're on holiday and stuff. So when we come back in September, we could actually do it upstairs and clear everything out for like long. We might be able to survive a little bit longer, but so we might need premises, but we definitely need to talk to speakers or anybody who wants to show demos or do lightning talks or do anything interesting in the group. That'd be great. So yeah, we've nearly 200 members now, which is awesome, and it's pretty cool actually for some group. So let's make it the best user group ever. I'm sorry it's so hot in here. The windows and doors are open. That doesn't go anywhere, so if there's a fire, don't run in that direction. You can, but it doesn't go anywhere. You can climb in from drain pipes. There's an exit there and there's a fire exit there as well. There's only one bathroom. I don't really care completely behind the shed, but yeah, welcome. So after last time, we asked everybody to get some feedback or fill out like a really simple form. And we got some really interesting feedback from that. One of which was that the speakers didn't really talk loud enough, so not everybody could hear. So we're all going to talk very loudly today, so if it makes especially Alex. And also that because it was the first meetup, everybody expected there would be some kind of like introduction to React. And I kind of didn't want to do that because like every meetup group, I mean, I've been to like I never got an introduction to Node, and I didn't want to like dumb it down or make it less interesting. Do you know about it, or it's a hobby or we're interested in it. We're all here for a reason, right? Because we like it. So we're not going to do that, but I will start with because like 3 or 4 people said, but we'll get onto some interesting stuff after that. So bear with us. The agenda is that I'm just going to do that little welcome and intro and what's new in React, and talking a little bit about the new curve tools in React and how we're going to how you can improve performance. So that's just like I'm going to roll that into one. Excuse me. That should say handling, I guess. 7:30, Alex is going to do a talk about Moriarty. I don't know if anyone's seen it or played with it yet. It looks pretty cool. Forbes is going to do talk on a new and then finally Rich is going to talk about using React and Ruby, which is what they're doing on this Sky project at the moment. And so it's got some interesting demos and things to show. So I think it should be quite decent. I don't know. Maybe not. So we'll see. What is it? Right, everyone says it's the V in MVC. I don't think it is. I don't think MVC comes anywhere into the equation. It can, but it doesn't have to. MVC is like the thing that everybody does, both client side and server side, for every web application all over the planet. And just because everyone does it doesn't necessarily mean it's the best way to do it. And new ways are coming along all the time. React's one of those, quite different to everything else. But if you're going to compare it to what everybody else does, then I suppose the V is the closest thing. But I mean, I think it's more a bit of M, a bit of V, and a bit of C. But it's really all about components. And I think this is modern web development is all about building components, reusable pieces of functionality that can be used anywhere in your UI, and that I suppose HTML itself is like loads of components. A div is a component, right? So React's just about creating those. Angular is too, and web components is as well, and lots of modern things. Component.js, lots of modern things are all about building components, and not so much about modular control anymore, which is quite good, I think. I think one of the best things about React is that it's non-intrusive. You can use it anywhere in your app. It can be a little tiny bit, or all of it, or a little bit on a page, or loads of different pages, or mix and match. It doesn't say anything about what else you use it with. You can use it with Backbone, you can use it with anything. One of the most exciting things about it is that it's uniform HTML5 feel to even old browsers like i7 and i8 stuff, and including an event model which is the same regardless of which browser you're working on. So all those horrible Microsoft event names and stuff you don't have to deal with any of them. And it's fast, right? So it works really well. I'm just going to talk a bit about performance later. So how does it work then? What is it? It's a bit, I think it's a bit like games programming, but not quite as exciting. I've done some games programming in the past, and it's weird with games because that's immediate mode programming, right? If you don't do anything, it's black on the screen. The pixel is black for that frame, and you've got 60 frames a second at least, and you've got millions of pixels on the screen, and you have to calculate the colour of every single pixel, every single frame, and that colour is made up from how the light reflects off your model, off your world, what the characters are doing in the world, what the physics is like, all sorts of things that you have to work out. And in the graphics card, the shader is working out the colour of that pixel, every pixel on screen, every frame. And that's a lot of calculation that's going on. But if you don't do anything at all, nothing happens. And then you've got retain mode, which is what we're used to, which is like, if you don't do anything at all, it just stays the same as it was. Which is what most user interfaces are built with. So React in my head is like a mixture between the two, because you can instruct, you can say that you can pour data in. So with games programming, you pour data into like a rendering engine, and that works out how every single bit of the screen is drawn. But you know, at the highest level, you don't actually have to do every pixel every second. You kind of just say what changes. This model removes or whatever, and everything else sort of, you've got a pipeline and rendering engine and just goes straight through. And React's a bit like that because you pour data in, and it works out what's changed, and then it will change just those bits. So it's a bit like immediate mode in the sense that you tell it what to do, and if you don't tell it to do anything, it won't do anything. It's much, much, much easier to reason about your application and how that application works, because you've only got to say, if the data looks like this, this is what to expect. This is what the screen should look like if the data's there. And that's why it's like games programming, because you would say, if this is there, then this is what it looks like. So it's quite like that. I'm not explaining this very well. Let's move on to the next slide. So how does it work? Right. So it works by creating a virtual DOM, a virtual representation of the browser's document object model, which is, is slow to update. So if you had to work out what every single element on the page looked like every single time any data changed, that would be quite slow. So what React does is it creates this virtual document object model, which is you describe what that virtual model looks like, given the data that you're given. You pour data on the top and say this is what it looks like, and then from that it generates some HTML basically, which injects into the document. So that's your first pass. And then if the data changes, you create another, from scratch, another virtual representation of the DOM. And React has some clever differing algorithms, and it goes through every single two, compares the two, generates a minimal set of changes, and then applies those changes in batch mode all at once to, and that's cheaper than having to recreate the whole user interface every time, which wouldn't work anyway because you'd lose your score position and where you are in the page and where your focus is and all that sort of stuff. So that sounds really expensive, but it's actually not, because modern JavaScript engines are really, really fast. And to build a lightweight DOM, a fresh lightweight DOM, and compare it with a previous lightweight DOM, is actually cheaper than building a brand new page from scratch, and then working out what needs to change. So maybe nothing needs to change, or maybe added an item to the list. There's only just like one node insertion into the DOM. So it goes down, level by level. So it compares the top level, then the next level, then that bit of the tree, then that bit of the tree. It doesn't cater for situations where you move something from one place to another place in the DOM. So if that bottom left moved to top right or something, it wouldn't deal with that. But it actually would, because it would deal with it in a different way. It would see it as a new node at that level, not a moved node from DOM. And then for lists and oh, sorry, just pressed a button. What have I done? There we go. When you're adding an item to a list, this is actually quite tricky, because if you've got a new item's been added to the list in data, and you want to add the same item in the UI, then where do you insert it? You can insert it at the end, that's easy. You can't insert it at the beginning, because if you insert it at the beginning, you don't, when you're doing the diff, you don't know whether it's changed, or the first one has changed to that, or whether it's been added. And it's actually quite difficult to work out what should happen. So they make another optimization where they you give a key. So if you pass an array of items and you want to render those items, then React will complain if you don't give it a unique key. If you don't give each item a key. So that's a list with 5 keys. We've added a new one, and it knows where to put it because Z is in that position in the input list, so it knows that Z is going in that place in the UI, and it can track the two, and it knows when it's re-rendering whether it needs to insert it and where it needs to insert it. So cool. It's a bit of a pain sometimes, but most things can get keys, right? It's quite easy to generate a key. Another optimization, if it's only divs, it just compares like for like. If the component is different, so basically if the component in the original tree is the same type as the component in the other tree, then it's up for looking deeper to see whether something else about the component's changed. If it's a completely different component, it will rip it out and put a new one in. End of. So it was just a wholesale replace. So it doesn't. Then that's faster because it doesn't actually have to go down and check inside. I mean, they might actually be very similar components. It's just the component itself is different. But it says if the component's different, it just replaces it wholesale. If you call set state in one of your components, then that component is marked as dirty in the tree, and so it and all its children will get re-rendered. So if you call set state at the top level, then the whole tree will get re-rendered. And when I say re-rendered, I mean it will basically be up for comparison. It won't necessarily regenerate the actual DOM element, but it'll be a candidate for comparisons. But if you only call set state further down in the tree, then it can just re-render different parts of the tree, so it doesn't necessarily have to do the whole thing. It will do sub-tree rendering. And then you can even improve on that with should component update. So if that returns false, then everything underneath that won't be a candidate for the diff. So return false from should component update, and its subtree doesn't get re-rendered. And we're going to talk a bit about this tonight because there's some interesting stuff coming up around that and about improving the performance of React. It's fast anyway, right? It's really fast, but you can make it like orders of magnitude faster by giving it hints about whether or not it should carry on differing in the tree below you. So we'll come on to that. That takes the next box to the next state, and you can compare it with this box in this state. And if you know they've not changed, neither of them have changed, then you can say return false, and that'll just shortcut that whole part of the tree. It's really good. So without any of those optimizations that we just looked at, you get order of n cubed time. So that's for 1,000 nodes, that's a billion computations, and that would be prohibitive, like by miles. And because of all those optimizations that we've just looked at, they've got it down to ON, so 1,000 comparisons for 1,000 nodes, and it can be a lot cheaper than that if you can return false on the short component update. So we're going to look at in a little bit about how we can, sorts of things we can do to return false from the short component update. React 0.11 came out last week. Really good, actually, I think. I don't think there's any major problems with it, but we're using it. Not in production yet, but we're using it, and we haven't really found any issues. A couple, but we'll come on to those. So what's new in it? There's always been a get default props, but previously it was called on every instance for every render. So this is a break and change now, because they only call it once per component type, once ever. So these are the default props that you would get if you didn't supply them. The props per component are. I'm going to get rid of this thing. Don't know if it's different. So yeah, that could be a break and change if you were relying on that to change the props or something before the render. Props should be passed in and really should be immutable. But if you don't pass them in, the default props should come from this method, and that's now what you want. The render method used to have to return a component, and it would fail if it didn't. Now you can return null. This is implemented using a no script, and that may change in the future, but at the moment it breaks HTML pages, which we're using at Tesco, and it's it won't work because I have no script. It's not part of XHTML, so new thing in JSX namespaces, you can have so UI there would be like node module or something that you created with a layout and a button component in it. So the module is UI and it exposes layout and it exposes button with and label there with module.export. So you can, at the top of the page, you can just require UI and it will reach into the module. Excuse me for those. And then there's this brand new event.key and event.get modifier state, which adheres to all the key names like enter and left arrow and all that sort of stuff. So you can test what key was pressed and what modifiers were down based on the names, which is quite nice. And a new on before input event, which I actually should have looked what it does, but I didn't, and I guess it flies. I don't know. What's broken? So we discovered this yesterday because we were calling set state in component marks, and we were calling it server side, and that fails because it expects a document to be present on the server. You don't have a document. So doc set's allowed. They are going to release a fix for it in 11.1 soon, but the discussion Pete Hunt said that he thought it was actually a bit silly to do that anyway, and you should just return the right state from the initial state in the first place. You only get one chance on to render on the server side, and get initial state is forgetting the initial state, so you should just return the initial state from that, and then you're done. So we refactored our code and fine, but it seems to work out for. And server-side rendering of option elements is difficult. So if you've got a select with options in it, does React to change the way that selects works? So there's actually very, very few departures from the WCC DOM, HTML5 DOM. but one of them is that selects have user value instead. So instead of a specific option being selected, the whole select has value, and server-side rendering doesn't work properly because if you set the value, it doesn't render as an option that's selected. So what you have to do is you have to force it and actually create the option that is selected yourself, and then React warns you that this isn't going to do it. Use select instead. So you can get around it, but you just get loads of warnings. So when we were using Node 10, we had to edit the code to suppress those warnings because it was. It might be the same again. We have told them about this. In the add-ons on Mod 11, there's some really interesting stuff. There's this mixing which helps you optimize the so-called pure components. So if you've got a render method that will always produce the same output if it gets the same state and the same props, then you can use this mixing we'll look at it in a second, to tell React not to bother rendering if the props or the state haven't changed. So it's like a step towards the holy grail of that we'll come on to. Perf, which is a new set of tools to help with performance analysis, we should look at as well, and the update, which has been there before, add-ons for update, which allows you to helps you to create immutable values so that you can optimize the rendering. Has a new apply command that can be used to transport all values, and some bug fixes with transition group, which we've also hit actually. So those perf tools, we'll look at those in a second, but before we do, we're writing quite a big React application at the moment, and we haven't seen a single performance problem on any. It's for mobile, and we haven't seen it on any mobile device. We haven't seen any problems whatsoever. So this is all rubbish, really, because why do we have to tune something that's not a problem? We can't fix a problem that isn't broken. But it feels like on really old devices or browsers with really slow JavaScript engines, that we can run into issues with really complex applications like a Gmail client type thing. Now, Angular hits these things all the time, right? So React would do too. And so they've given us some perf tools now, which we can use to show what's happening. They're quite good fun, quite interesting to look at, to see what when it's rendering, where it's spending time. So we're going to look at print wasted, which prints the time it's wasted rendering your application. So if you imagine, like when it's doing the diffing, if it has to do all the diffing, and then when it gets to the end of the diffing, it realizes that actually nothing's changed, then that's a waste of time. If it gets to the end of the diffing and it's found that something has changed, it's not wasted time, right? So that's the difference between the two. But if I want to go to? I go to there. So this is the React Flux to do MVC. And what I've done is I've just instrumented it briefly. Let's have a look at the code first, actually. So, is that big enough? Can I see? No. Right. Okay. So, I don't know if you've met Flux, but it's like a pattern for one-way data around your app, like this. So, it comes through. All the data comes through this dispatcher, and so. What I'm doing is I'm starting the perf tools are in the add-ons, in the React add-ons. So just starting the perf tools there, and then every time there's an action on the page, we print how much time was wasted on the render, and then start the whole thing off again. So that kind of resets all the counters. So every time there's an action, we just print it and then start them again. So in here, and I can probably make this bigger as well. And this probably. Okay, so okay, it's not really worked. I want some space down here. So if I add down here on the right, this is in the console, it's printed a table of the components that wasted more than a millisecond rendering. So this is the first thing that I did, right? And the header component to do text import, the root to do out header, to do out to render the header, wasted 3.7 seconds. There's 14 instances of to do text import, one instance of that, one instance of that, and that's how much time was wasted. And then if I add another one, then this time the only thing that was wasted over a millisecond was the to-do items. Yeah. Can I do what? Move the console up? Yeah. I'll do that. I'll do it. Is that better? And then each one I add. So now I've got 8 instances, 9 instances of this to-do thing. I'm just going to use it. And the time to render the app is going up and up and up. So we've got 8 seconds or 10 seconds. And occasionally some other components take a little bit of extra time. 65 instances. It's only taking 8 milliseconds of wasted time in there. On a complex app might be more interesting. On this side, probably really boring. But we can improve that quite considerably just by using this pure where is it? This pure render mixin. So if I add this mixin in, which is React add-ons pure render mixin, we'll look at what it does in a second. Actually, let's look at what it does now. So this is the pure render mixin. All it does is it requires this shallow equal, and then in the should component update, it looks to see if this.props has changed from next props, and if this.state has changed from next state. And that shallow equal just looks like this. So if the object instances are exactly the same, returns true, and then if any of the properties values are different, returns false, and if B is missing any properties that A's got, also returns false, otherwise it returns true. So very, very simple check based on identity and reference equality. And that's what it does. So if you add that mix in there, it basically supplies this component with a should component update that just does reference checking. So add that in there. So now if I refresh this, the first one's pretty much the same. Second one, pretty much the same. Did I rebuild this? No, I should do that actually. Okay, now let's try it again now. Otherwise we'd have got to 65 and they've all been the same. First one's pretty much the same. Second one, 1 millisecond waste of time. And now every one I add doesn't waste any time at all. It actually isn't doing anything. So when I get down to occasionally we get one, but none. And when I get down to 65, I can't even see how many I've got now because it's not showing me. No, it's not. It doesn't report on stuff it doesn't think it's worth reporting on. So I must be at 65 now. Let's see, 82, and it didn't take any time at all. So silly little demo, but it's shaking for a millisecond here and there. But if it's a big complex app, and you've got a massive rhetoric hierarchy, and you know that it's not going to change, then why fall all the way down to the point two? Okay, so that's interesting. This is leading into Alex's talk, I think, because he's going to talk in a bit more detail about not just yet. Yeah, maybe it is just yet, actually. Let's have a look. So we talked about pure render mixing. So what does React give you to help you with that? By guaranteeing immutability. So if you can say to React, I guarantee that if an object has changed, it will be a different object. So if you've got the same object and it hasn't changed, right? If nothing inside my object will have changed. If I give you the same reference as you've got already, then nothing has changed. If I give you a reference to a different object, then you better check if it has changed. So in the add-ons namespace is this update, which if you give it your old data, that's your old state, and the updates that you want to apply to that state, it'll give you a new state, which is immutable, or is a different instance from your old state, where all the bits that have changed are new objects, and all the bits that haven't changed are the same references, same objects. And so effectively, if you use this update, you can guarantee to React that the data is immutable, and you could use that new pure render mixing on every single component with impunity, because you would know that no matter how deep you go down, because at the moment that pure render mixing only does shallow stuff, like if you don't notice, it only just compares the object itself for a reference equals and its properties. It doesn't go delving down even deeper, so it doesn't. Sometimes it doesn't work. If you've got a deep object graph, it doesn't work. But with this, it would, because if you use this update, then it guarantees that the new data object is it's a different reference for everything that's changed. So let's have a quick look at that. Excuse me. Too much beer. Right, this is live. This is live script. No apologies for that. What I've done is required React add-ons as React, and I've imported all the add-ons onto the global namespace, so I can just use them as they are. I don't have to. We'll see that in a second. In fact, this is the update here. I can just use it as it is. I don't have to say add-ons.update or whatever. This is my old data or my old state, effectively, and I've got an object. It's an object with a property called x, which is an object with a property called y, which is an object with a property called z, whose value is 5, and also has a, which is b, and it's an array of 1, 2, 3, and b1 is 7, 8, 9, and there's an s and t and a u. So that s is an object with one property t, and t is a object with one property u, etc., etc. So we'll look at that. If I put a return in there, then that's what it looks like. I can make this bigger. Come on. Oh, that doesn't work, does it? It does. There. X, Y, Z, 5, A, B, 1, 2, 3, B, B1, 7, 8, 9, S, T, U, 1. That's what it looks like. And then instead of editing them directly, so like saying old data.x.y.z equals 7, if you use this update from React, pass in the old data, and then pass in an object of all the differences that you want to do. So this is like in x, in y, in z, set that value to 7, and in a and in b, push the values within this array onto the existing array. So it's saying set this 5 to 7 and push 4 into here. It's taken this from MongoDB syntax. I don't know if anyone's used that, familiar with it, but and new data will be an object that's got those values changed. So this is the first one, which was Z5 and B was 1, 2, 3, and this is the new one, which is also, oh no, that's the first one, Z5. Did I put the return in the wrong place? Oh yeah, I did. So now this is the new one, which has got Z7 and B 1, 2, 3, 4. Not very exciting, really, but this is the good bit. This bunch of console.logs looks at all of them and does a reference equals between the same point in the new one and the same point in the old one. So if I run it with that, I see that data isn't, so I'm comparing with isn't. So data has changed, so that isn't the same reference. Data.x has changed, data.x.y has changed, data.x.y.z has changed. Data.a has changed, AB has changed, but AB1 hasn't. We didn't change that, so that's still exactly the same reference. And S, T, and U haven't changed at all, so they're exactly the same references. I suppose if I change those isn'ts to is probably might actually be. So those are the ones that aren't, the falses are the ones that aren't the same reference, and true is the same, well, it is the same reference. It basically changes the object for a new one and replaces the object above it and the object above that all the way to the root. But putting the old objects that haven't changed back into those as well. And then when you pass that to your React component, in the should component update, you can just compare it to using reference equals. And then if they're the same, it knows it doesn't have to go and move that. So as well as set, we looked at set and we looked at push. There's also unshift to put its stuff at the beginning, splice to put stuff in the middle, merge to merge all the keys from one object into the target, and apply to apply a function or apply the return value from the function call into that place. So I haven't used it yet, but it feels like it could be useful. When you're updating your state, use the update instead, and then put the pure render mixin in, and bingo, you've got really fast rendering. So that means now that with this, pure render mixing will work with deep hierarchies, whereas it wouldn't before. What alternatives are there? You can get immutability using LiveScript with Prelude. There's Mori, which Alex is going to talk about a little bit, and of course there's ClojureScript with ON, which has got all that built in because everything in ClojureScript is immutable, and that's the way ON works. So I think React is sort of kind of moving in that direction, but anyway, that's me. It's you now, Alex.
Oh, yeah. I'll do it.
Stick that in there.
Okay. How do you use it? There's one button, it's too complicated.
So that's the laser, don't point it in anybody's eye. That's the laser there. That's left, and that's backwards and that's forwards.
Isn't it? It's just try to kill people's sight with röntgen, like the X-ray. So he was actually like pointing an X-ray in his eyes, and he almost got blind, and then he hated the X-ray. Yeah. So. Application state handling with Moriarty and React. I will be going like towards Moriarty through a few topics, and let's start with a little bit of so. Very simple form, and there's like few input fields, and there's a big button to submit. And if we are doing this form with React, we will probably divide it in a few components. Like there would be separate component for the input field, probably a separate component for those grouped fields, and again like separate components for each field of those with validations and nice UI feedback and visualization. There will be also separate component for the submit button, maybe not, but probably. And then the whole form will be a separate component, and then probably the whole pop-up will be again a separate component. We'll have like a nice hierarchy of UI components interacting with each other. And the topic I want to talk about is basically application state. So in normal MVC approach, you have like a model which has the whole data which kind of tells the application and all those UI bits what to display, and if something's changed, the user has changed something, it will be communicated back to the model and it's kind of stored and maybe communicated to other bits. But in React, it's a bit different because, well, we don't have model already, as Stu already mentioned. But instead, we have states and we have props. And if you go into component A, component B, and let's imagine component A is like a parent component, component B is like a child component, and so usually in component A, we would communicate, like we would to, how do you close it? Was there? Oh, no. It's too complicated. Was it the big button?
No, the bottom one.
The bottom one? Does it work? There again. You have to press really hard. Right, so this is a component A, which is kind of parent, and this is component B, which is a child. And now in this component A, we are in the render function. We are kind of creating the component A, and this is again a little bit of TypeScript. So this is why it looks so nice. And like this is a do block, and then this is like property A of the component A is equal to the state of the component A. So we're kind of linking the state of the component A into the properties of the component B. And then when the state of component A changes, this is magically transferred to the component B, and component B can display those changes. And what do we do if component B wants to communicate some changes back to the parent? Then what we can do, we can supply a callback, and then in the callback, we can do like set state C to it, which is default parameter when you call the method, and then so in component B, on say on my input, we would do on change, and on change we would call this on change. This at is kind of this, and here is this on change. It would basically call property C, which is here is our callback. So this property C is basically a function. So we call it property C with value, and value is the one that we get from onChange. Probably actually it, because again, like the only parameter we call. So, and this will end up calling this callback actually from the child component in the parent component, and it will. Oh yeah, so the value will end up actually in this, and the state of the component A will be updated from the child component. So it's a little bit. So, and if we go further, so this is a tree of the components. Again, we have a parent components, child components, and then some of them again parent. So, and for example, this component has its own state, and this component has a state which is also communicated to this component, and then there is a little bit of state like shared between this, and this. And you have like state of the whole application is kind of, it's been all around the tree of the components. And some people see that as a problem. It's actually might be a problem when your application grows huge. So there is Flux, and the Flux basically how we implemented this, and I think we implemented was how Facebook recommended to do. So you have dispatcher on the very top, and then you have stores for the components. Some stores, I think, can actually combine states from multiple components. And then dispatcher is like a very central place, and everything goes through the dispatcher to the component, and then components communicate through the dispatcher to store and so on. But again, I mean, the actual data is in stores and components. Well, yeah, so. And there's OM. OM is a ClojureScript interface to Facebook React, and many of you probably already has it from Stu mentioned it many times. And OM is very interesting because OM is built on ClojureScript, and ClojureScript is an interesting language because it's built on top of, well, it's basically Clojure, and it has immutable structures in its core. And application state in OM is single atom. If you ever done Lisp, atom is like the very basic thing in Lisp where you build amazing things. It's like it can be as tiny as like very simple thing like operations, like some parameters, but then it can grow into huge things as well. So the root atom contains all the application state in OM, and then you have components, and what components have, they have cursors, and cursor is basically like a subset of the root atom. So like you get this reference to the atom. The atom is a immutable structure. So it's a symbol structure, sure, in a second. And in OM, everything is in one place, really, and then just gets communicated to the components. OM also takes over of the should component updates, and it uses this very nice trick to actually optimize the performance really well, just because you can rely on the immutability of the application state. You can do these kind of things. And should component update by default always returns true in React as of now, but well, as you again mentioned, you can take over of that and especially if you know what you're doing, you can improve performance. And this is actually an example of the React MVC, and they have this comment, even like in the React to do MVC example. It's usually better to use immutable data structures. Immutability. Immutability is a very interesting topic because usually, like in most languages, we use variables. You can, well, basically, you have a variable and then you set a new value, and it's getting rewritten. And immutability effectively means constants. So in LiveScript, you have constants, and you can define like constant and then you try to redefine it, it will give you an error. Obviously, it compiles into JavaScript later on, but on compile time, it will actually give you kind of errors if you try to redefine constants. So constants actually have anything in LiveScript. And you can also use object freeze in JavaScript, which effectively freezes the whole object and makes it immutable, and then you can't do anything about that. It won't give you any errors, but it will fail silently to update any of its value, or if you want to add extra properties to the object. So like if it's frozen in true and like you try to redefine it, it kind of gives you okay, but it's still exactly the same object as it's been over there. And this is basically immutability in a nutshell. It's just stuff that you can't change. You define it once and that's it. And the system knows that you can promise it that, okay, it's not going to change. And system, aha, you're not going to change it, so I'm going to optimize the hell out of it. So immutable objects are easier to reason. They're thread safe because, well, when you do multi-threading and concurrency, you can rely the state this other thread not going to change it because it's immutable. Better security, I guess, as well. And references instead of copies. So when you try to change the immutable object or structure, instead of modifying itself, it will render you a copy of itself and return it to you. And this is how we got to persistent structures. So I mean, simple variables are not as fun, but persistent structures are kind of more interesting thing because they can yield a new structure, modify, and they can preserve the previous version of itself, and then you get like a huge timeline history of the whole state of, in that case, the whole application. They can be partially persistent, which means that you can only get access to the very last one and the one before it. They can be fully persistent, which means you can get access to any single kind of moment in history of the style structure. They can be confluently persistent if you can also like take two of those members in history and meld them together. And ephemeral basically means everything else, which is not persistent. And this graph I took from Book of Closure is kind of give a more like illustrative reason, but it also tells you a little bit of performance. So, like when you have a normal array, and when we try and find the value in the array, so we tell the system, okay, please check if there is like in this array if there is value R. And goes like, okay, let's check first one, let's check second one, let's check third one. Goes through the whole array. And the worst case scenario is that it will have to do as much checks as the length of the array. And in Closure, they have persistent structures, and this, I think, is related to the vector in Closure, and it has a complexity rate of logarithmic 32, which means in the very beginning of the check, the linear is basically a normal immutable list. So if the list is shorter, you can find operations much faster just because it's shorter. But a vector will take much longer time because of its nature. But then again, when the length of the structure grows, the normal mutable list will take significantly longer time and it kind of keeps on growing. But vector in Closure, it basically becomes almost at the same time. So to I think for example, like if there is like 1 billion members in the same structure, it will take almost the same time as if there would be like 1,000 members of the same structure. If you go back to the JavaScript, there is Mori, and Mori is Closure script persistent structures implemented in plain JavaScript. And Mori got vector. And vector is persistent structure which supports efficient addition in the end. They also support efficient random access. And then there is also hash map, which is more interesting in a way that you can have like more. So the normal hash, like you have a key name, you have value, key name, value. But then again, in Closure, you can have, instead of key name, you can have like an array or a vector, and then you can get the value out of this. unlike JavaScript object, Mori persistent hash map supports complex keys. It's recommended that you only use immutable values for your keys, numbers, strings, or a Mori collection. And now we talk about Moriarty. Moriarty is better state management. It's basically like a norm, but written in JavaScript. And the guys that were doing the Moriarty, they kind of wanted control over the application context in a single place, but they couldn't use closure script for some reasons. So they end up basically rewriting persistent data structures, and they also made their own kind of application context thing, which we are going to talk about. So single application context, meaning all the data of the application is stored in the same place. There are persistent data structures that they have re-implemented and all in JavaScript. Yeah, so I'm going to show you. This is application we're going to go probably quickly through. So it's one of those to-do MVCs, and this one is written with Moriarty. So very simple one. You can switch between the states. You can switch to like completed. You can cross those out, and you can complete some tasks. And yeah, those dudes also, they did a bit of performance check, and they actually claim that Moriarty hash map is faster than the Mori hash map. The longer this blue thing is, the better. And it means you can do more operations per second. And they also did comparison of the vector implementations they did, and turned out that Mori is actually better than what they did. But what they now they're going to re-implement the vector using RRB trees, and which probably is supposed to improve performance quite a bit. And yeah, so the basic building blocks of the Moriarty. There's Moriarty binding object, which is basically a wrapper around the persistent data structure. So there is a single persistent data structure which contains the whole application state, and binding is effectively like a wrapper. So, around it contains the whole application state. Also allows you creating of sub-bindings, which is really nice. It kind of like cursors in OM. So when you want to share the state of the application to some small components, you don't have to share the whole thing. You can just share like sub-binding. And the binding object also allows you creation of the listeners. Then there's Moriarty context, which is like a central module of the application and gives you access to utils, bindings, history, data structures, and you'll see in a moment. So, and here's already an example, like when we create a context. So the first thing you do in Moriarty application, you create the context of the application. And in this case, here's like a state. In which mode are we? Are we showing like all of them? And then here's one item of the to-do list. This is the very first one, which we see by default. So it has a title, it has is completed, not, and if we editing it. And we created this Moriarty create context. And this is how it would look in the live script. And here's an application. And again, I'll switch to live script. So this example actually using a simple router called director, and in director we are binding state of the now showing to the now showing call. And on render we create those some components, feeder, to-do list, and footer, and we pass the state. So this add get state effectively gives us the whole state of the application from the context. And yeah, so it's just open the actual source code. So yeah, that's a context. The bootstrap basically kind of bootstraps the whole application, and you get a state from the context. There is this simple immutable object for the states of the application. So I was showing like all of the items on the active, so the completed ones. There's the router, and now we're getting into the actual subcomponents. So this is a header, and on up to do is, yeah, so here we're rendering the actual component, and on key press, go up to do. So this gets access to the to-dos of the state, which are these beats. So we are appending a new item into the to-do with the title, complete, editing, and in a to-do list component, we create here's an interesting bit. We create like item bindings, and then we create like a sub binding from the actual state. So we only take like items, not the whole state of the application. Just render to do all completed. And yeah, and here's to-do item component, which also operates on application state. So here's an interesting bit. Again, what Moriarty provides, it provides you ability to do transactions. So you can get a title and also editing property, and then you can commit those at the same time using this atomically method. So instead of, yeah, and this will save you on render time. So every time you change the state, it re-renders the components which are affected by the state. So if you do atomic changes, it will kind of render it only once instead of twice. And communicating new value to the application states. And yeah, so 200 plus lines and single context of the application and immutable structures as well provided by the Moriarty.
So anytime you touch any of that state, it will automatically render, as opposed to influx, you have to trigger an event.
Well, only if you subscribed, actually, I think. So just fine.
So you never render explicitly, correct? Always happens because you change something.
Yeah, I think you're supposed to subscribe to the method. So let's see. Oh well. Right, so feature development. RRB trees for vectors better documentation. The documentation is actually lacks a little bit. They kind of generated the whole thing, but you can pretty much get information out of what they have. They also like looking for the community feedback. So they're using one production application, but they're not really. It's kind of at the moment they just publish the whole thing and waiting for people to give them some feedback. And yeah, just a little bit further review. So, yeah. That's it.
Does someone have any questions? Someone have any questions? Victor, I think you probably must be right, actually, because if you get an if you call atomically to get like a transaction context and then do like some stuff and then for commit, then I would imagine that if you don't do that, it happens immediately. Yeah, it's really cool, but I don't know what happens if you want to update two different parts of the state at the same time, whether you can combine into one transaction.
Yeah.
Cool. Okay.
Right.
Paul's just going to do a talk on Moped now. So. The cable. Do you want to join the airplane?
Don't know. I haven't done it without airplane before.
You just click that at the top. You can use the cable, but I don't think it reaches very well.
I didn't realise that was an option.
It's that one there. Get to 2.
Oh, magic. I'll leave that.
Yeah. Everyone's getting beers.
Yeah, I'm tempted to just leave them and give them 30 seconds to get beers.
Shall we do that?
Yeah.
You've got 30 seconds to get a beer, right now. 1 minute, 30 seconds.
Feels more sensible than having a load of people sitting down halfway through. So I'll be the third person. I don't know those bits. I need to work out what those should say.
Third to do MVC.
Yeah.
Yeah, hi.
Thanks so much for organising.
Oh, that's right.
I'm from Moon.
Okay, yeah.
I tried to send you an email, I didn't get it.
I know that one.
I'd love to host next time. I've got
Oh.
really big spaces here.
Yeah.
And we'd love to do some talks.
Yeah.
Can I get you on people with this guy company, I think it's probably one.
Yeah, somewhere in there. I've got some friends. So we said we weren't going to do one next week, but if you want to, you can. I mean, we get out of that. I don't think it will. I thought we tried to break it into yeah, because we are going to run out of space.
Yeah, I don't know, probably. Okay, I'm gonna get started, I think. As soon as everyone. Cool. Okay, so I'm going to apologise right away for the fact that I've got the same to-do MVC demo up as the last two speakers. I didn't know that in advance. I'd have found a different to-do framework had I known. But anyway, so this is a little bit different. I've spent about the last 4 days building this particular to-do MVC demo, so it's over-engineered as much as it possibly can be. So this is a real-time to-do app. So if we put, we can see that I've typed into one and the other updates instantly, and I can go into the other one and tick a box and I don't know, use React. So it's a real-time collaborative to-do application, and anyone can use it, and if they've got the same ID at the end of the URL, they'll be editing the same list. And it's most of the way towards the point where it'll only download the to-do list that's currently being edited, although there's a little bit more code to write before that actually kind of fully works. It also renders server-side, so this particular client doesn't have JavaScript enabled, which means that editing stuff won't work, and it also means that if I edit things in the other tab, it won't update automatically live, but if I refresh, I can at least see the static content, which means your search engines can see it. It's a bit faster in that it loads straight away, even if the JavaScript hasn't yet been fully downloaded. So it does all of this, and that's kind of the key goal behind Moped, is to make it really easy to write applications that have these features that do the real-time sync, the rendering server-side and client-side in the exact same way, and hopefully in the future working offline as well, although that's still to be implemented. So what does the code look like for this this highly over-engineered to-do MVC app? So this is a simple Node.js web server that loads Express and Jade, which is our templating engine. It also loads Moped, which is the new framework that I'm introducing. It creates an Express app, and then lower down it does app.use and uses an app, which we'll come back to in a second. It then does an app.use for express.static to load the static content, so that's just some CSS and some images and boring stuff. And then at the end it listens on a port number. So what's interesting is this Moped thing. Here we've specified a layout to use and a transform of React Jade, because I'm going to use Jade to do my React rather than JSX or manually creating React DOM nodes. But Moped doesn't require you to do that. Moped lets you use anything. You could, if you wanted to use JSX, you could just substitute JSX in here in place of React Jade, and then go ahead and use JSX. So that layout file that I've created is a very simple Jade view. So this is just the boilerplate of the HTML. The goal is not to have your application in here. It's just to have the doc type and the head and the links to the style sheet, that sort of thing. And then it's got two placeholders that are provided by Moped. The first of which is the component, which is where the body of your application will render. And the second is the client, which is just where the script tags will live. So the body of that application is actually another Jade view, but this time it's a React Jade view. So this will be rendered to a React component, which is that input at the top and the list of tasks, and then view controls at the bottom for navigating to completed and active and for clearing completed items and that sort of thing. So then the actual app itself, so this is really the meat of the application, the meat of the Moped application. So we start by creating a new Moped app at the top there. We're using React and React Jade. We're not actually using UID. That line of code is completely redundant. We're then compiling our two templates, so one of which is for the index and one of which is for the temp page on which you've actually got the task list. I haven't really shown you the index. We have a couple of items of state that are just two things being edited that we're not synchronizing, so store those separately in a variable. And then this application model is a bit overcomplicated because I was figuring out how to get all of the necessary APIs for handling key down and key up and keyboard navigation and all sorts of stuff that to-do MVC demo expects you to do. But the interesting bit is that we've got this notion of a database on the client side, which behaves very much like a MongoDB database, except that it's synchronous. So here we're just doing db.todos.find, and we're saying find all the ones where list equals this._list. And for example, when we do toggle all, we say db.todos.update, all of the ones that have the list set to the current list and set their completed value to checked. Toggle says update the one with this ID to have completed set to not whatever it had before, and so on. So we're just calling into the database as if it was a MongoDB database but running locally, and running commands on it to update that data. And doing so automatically refreshes the application and also synchronizes that state to the server where it gets sent out to other clients. So it's 150 lines of code for the entire bulk of the application that does has all the necessary stuff built into it to do all the data sync. And you can see at the bottom here, we say, so this sets up the synchronization and defines the location for storing the data on the server, and also what data is accessible to the client. So this they're putting sort of list, setting the list in there should allow you to override to filter the data so you only get the current list, but that still kind of needs implementing. You've got express style routes here, so app.get/ renders it returns so each of these routes returns a React component that Moped then renders. So if we return, this call to render returns a React component, which is the application with all of the to-dos visible, and then this one returns that same React component but with only the active to-dos, and this one with only the completed to-dos. And those routes get accessed the exact same way on the server and on the client. You can have multiple of these apps in one Express application. You can multiple Moped apps living in a single host for different parts of the application, allowing you to break up the code and break up the data. And it will automatically, if you do put the stuff in to have it only download the current list, it will automatically just reload the page completely. If you navigate to a different list or to something that's not actually been downloaded, it will just do a full page load from the server to get that new data. And in that initial page load, all of the original data is supplied. So under elements, this script tag there, I don't know, can I zoom in enough to make that visible? So So it's got the state of the server database and where that is, and various information there, and data attributes on that script tag as JSON encoded stuff to initialize that client-side database. Okay, so the synchronization is actually done by a completely different component, so I wanted to just show you a little bit of how that works. So the goal of Moped is to be as simple as possible and to hopefully avoid you having to think about how the data sync happens and what's going on behind the scenes. But it's also very deliberately built to live inside the Node.js ecosystem, so you can carry on using any of the other Node modules that you're used to. And it's also built out of modules itself, so that hopefully you'll be able to go, I really hate Moped, but it does this one really awesome thing, and if you think that, then you should be able to, I want you to be able to grab that bit of functionality that you like and throw away the rest and just use that bit, because that should lead to more awesome ideas, and hopefully someone will go, you know what, this Moped thing is terrible, but you got that bit really, you did that bit really well, and they'll go and build something better, and then I'll stop maintaining Moped and use their thing. So this is just showing off how the synchronization happens. So I've got running inside the browser all of the code for 2 clients to this synchronization system and 1 server. And I've created a collection called cars, so I can insert stuff into cars on one of the clients just by running. If I zoom in, will this break the layout horribly? No. That worked remarkably well. Okay, so I can call db.cars.insert and insert a car with a make of Honda. And if I run that, then the local database on the left client, has this car in it with a make of Honda, and it gets an ID auto-generated because we didn't provide one, and that ID is a MongoDB-style object ID. Having done that, we have this upload, this change that's queued to send to the server. So if I manually, I've artificially made it so that I have to manually do each network operation. So I can send that change to the server, and I now see that the server has that change, the original client has that change, and there's a change queued on both clients to be downloaded to add this to the local database. So getting that change on this side does nothing because we've already got that change, so all that does is updates the client to realize that that change has been committed on the server. And then on the right client, getting that change will complete the synchronization and insert that item. I can also do updates though, and I can update my Honda and say that the color of my Honda is red on one side, and then I could simultaneously update the same car on the other side and say that it has leather seats. So I can run that. So now I've got 2 updates queued to the same object. So I'll send one of them to the server, and the server will now update. So it knows it's a Honda, it now knows it's got the color red, and I've now got changes queued to download. So this one is just committing the same thing, so let's just get rid of that one. But now what's interesting is this state where I've got a change that is waiting to be uploaded and a change that is waiting to be downloaded to the same object on the same client. So what happens if I download this change now that sets the color to red? Oh, that's going to lose everything. Yeah. Oh, damn. Yeah, gestures are a terrible idea. Okay, now we're back where we were. So, if I now get that change from the server that sets the color to red, then both changes just get merged on the client, What's happened there is that the changes that happened on the client happened on the client but had not yet been fully committed were all rolled back. The change from the server was applied, and then all of the local changes were reapplied after that change from the server, which leaves us with a nice consistent state on the client. And if we then complete the change, sending the change to the server, and then get it back to both clients, they're both synchronized and they both have the same state. So that's how the state synchronization is built. It seems to fairly robustly always end up with the same thing on the client. At the moment, I've only built an in-memory implementation of the server. So my next task will be to build a MongoDB-backed implementation of the server, and I also plan on building a MySQL-backed implementation of the server. It's built in a way that should make that pretty easy and pretty simple. And everything on the server side is expected to be asynchronous. So then you should be able to fire up a Moped app with any kind of backend you like, any backend database. So yeah, I think that's pretty much everything. So yeah, if you want to contribute, these are on GitHub. There's a Moped project, which is the framework and all the really opinionated stuff. And then there's Moped Sync, which is just that really basic synchronization stuff. They both completely lack docs at the moment, but I'm going to be on that very soon. Moped really needs a logo. Someone needs to draw me a moped. And then I'm going to start setting up a website and everything, and it'll be all go. But I just wanted to show it to people and get feedback. So at this point, everything is subject to change, and tell me what I've done wrong and what's stupid and why it really won't work the way I'm doing it. That'd be great. So any questions, any suggestions right now? Yeah?
Obvious, what if you change the same key in both clients? What happens with the conflict?
The last client to write to the server wins at the moment. I may look at providing some ability to customize the conflict resolution, but at the moment the server is expected to be able to fully serialize the updates, and essentially the server decides what order stuff actually happened in. Anyone else? No? Okay. Thank you.
No.
Okay, I'm going to talk about isomorphic React in Ruby on Rails. So what does that mean? Isomorphic, as you've probably heard already, is in our case capable of switching seamlessly between server and client-side rendering, even mid-interaction. React is your favorite UI framework. Ruby on Rails is a web framework. I wrote legacy, but I'm not sure how many people use Ruby. Oh, so it's not that legacy. I was kind of hoping to please the node crowd, but it doesn't seem to be that popular. So why on earth would I want to do that if it's so nice to do JavaScript on both sides? So I got a Rails app, and I want a single page app in it because I have something that has really complicated interaction. I also want to work in browsers without JavaScript, or deep linking, be search engines friendly, and also hopefully be fun to write. So that's where this gem called React Rails comes in. React Rails is a really simple gem that's maintained by Facebook. It's about a year old. It's really small. You can read it in about an hour. And it supports server-side rendering using exec.js, which is the JavaScript runtime wrapper that Rails or Ruby has to do asset pipeline rendering. So when you run CoffeeScript in Rails, it goes through exec.js and compiles to JavaScript and packs and minifies and does all that stuff. So this is the same pipeline that it uses. You install it by adding it to a gem file, and then what it gives you is this very useful helper in the view called React Component. You give it a name of your component, you give it properties, which is just a Ruby object, plain, hashes and arrays, and you say pre-render true, and that is the key to the isomorphic part. And then in your JavaScript file, you have a component down there called Meetup component, same as here, rendering something, and that will render server-side, and then client-side React will take over and do the same thing. So when you interact with it, you'll be in a single-page app. So next up, I have a demo, and this time it's not a to-do app. It's actually a real production app, which we built for Sky. So sorry about that. Last time Stu asked who has a React app in production. I couldn't raise my hand, now I can. Who has a React app in production now? Okay, just me. It's not very. There is one. Partially good. See, that's what we do. So this, what you see, is a help site where users go to resolve their problems with Sky services and products. This is not React. That's just Rails rendered normally with Slim template or something. But when you go here, this is a React app, and you will see why, because it does all these things, filtering up. Sorry about that. Filtering down by products, intents, and topics, and it's also responsive. So it switches to a completely different view for mobile, but the state is synchronized, which is what React is good at. So if I do how to use account connection and go back up, hopefully eventually it will do how to use account and connection. And if I turn off JavaScript, it's really slow with the streaming. Disable and click something like SkyTalk. I'll think for a bit, and I'll get the same page, but from the server. And again, fix, same page, Sky TV, turn JavaScript back on, click something that will render on the server, but now the client will take over, and it's just local. And it does URL updates up here. So when you copy that link, open a new tab, paste that link, you get the exact same state again, so you can send someone the URL. And that came from the server and continues on the client. So that's it. That's as much as I have code, but how does that actually look in reality? So we have a component called index page that does all the rendering. We pass in the properties. Props is a Rails view helper that takes the collection of articles that come in, which has articles and all the products, intents, and topic tags that the articles are tagged with. And the helper adds a URL template, I think, which is something we used to do that state update in the URL. So we have to have that client-side as well, because we're doing the same thing. It's the same code. And that produces that HTML, which is a div with data React class, index page, and data React properties, and there is a massive JSON in here which came from that. And it has pre-rendered true and has the rendered HTML in it, which is what we want. Client side, it's pretty much nothing except this, which is an initialization of the whole state handling. So if we have Mr. Push state, we register an on-top state handler that updates the selection, and you can see that we have a thing called dispatcher, because it is essentially a Flux architecture. But that's as much as we do before actually rendering the component, which you don't do manually with React Rails. It just happens for you because it finds that HTML in the page with that, and so it says, okay, that is a React component, so I will call render component and place it in that div. And because it's tagged with the hash and everything, it will resolve itself and re-render and carry on with JavaScript. And so the Flux architecture we use is the typical one. We have a store, we have a dispatcher, and we have the view components, but we cannot instantiate them one by one in some JavaScript file that gets run when the browser opens, because we also render on the server, and we're going through that view helper. So the store and the dispatcher have to get initialized as part of the component. It's the only change between that and what you would do on Node, I think. So when the top level component mounts, it initializes the store with the props that it got, and then does something with the URL helper that manages the state in the URL, updates the selection based on what's in the URL, and then carries on as usual. And here are some things to avoid when you do React on Rails or without Rails. Generally, you can't use browser APIs because you don't have a browser on the server. So you can't do window dot, you can't do jQuery, you can't do even console, which is interesting but React Rails specific, because it's run in the exec.js, which internally has just a plain V8 that has nothing in it. So it doesn't even have console, it doesn't have really anything, it's just plain JavaScript. And we had a problem with that because React itself internally uses console dot something, so we had to submit a patch to React Rails to fix that. And you should also probably avoid massive data set in that in the props field, because that would create a huge JSON thing that will then dump into your DOM, and you'll have to load it again. So it adds some overhead to the processing, because if you use Active Record, you will load things from the database, instantiate all the models, then convert them to JSON, serialize them, put into the HTML, dump into the V8, render the HTML. So there's like an extra step where it deserializes all the JSON, instantiates all the objects for your components, and renders it. So the less you do of that, the better. And then on the client, the same thing happens. So it's kind of slightly slow. Caching is a good idea, but you get some benefits as well, especially because it's Flux. This is how we do analytics on the clicks. You can just listen to updates on the dispatcher. So if dispatcher gets update selection, which is what happens every time you click anything in the blue pills, just set up what the analytics should do, track the page, and you're done with it, and that can be in a separate file. This dispatcher is a global variable, so it's fine. And that's it. Thanks. That's all you like. Any questions? Cool. That's it. Oh, there's one.
Are you using the beta version of React Rails or the current master?
We're actually using our own fork of master because of that bug fix that we did. We have got one pull request merged in, we have one more we're waiting on, and then we'll switch back to master on the React Rails. Okay, hopefully they will eventually release it.
I heard that the releases tend to lag quite a lot behind master.
Yeah, I think the current stable version doesn't even do the server-side rendering.
No.
So the master does it, and it's quite stable. It works pretty well, except for those two problems.
Just to recap, you're running the React JavaScript program, to HTML,
yeah, from Rails on the server side, and then again in the client and carry on with it. But it's not exactly fast.
That's alright.
And it's like in the order of hundreds of milliseconds, but it adds to whatever your Rails app is doing already. And you all know that Rails aren't really quick. But yeah, it's like, you can work with it. It's not awful. And you can cache a lot of stuff. Probably your state doesn't change that much. You can cache the whole rendering thing, so skip it.
HTTP show is not.
Well, there is a huge network setup around it. So there is a thick Akamai cache in front of our actual application, which only sends 1% of requests back. So what we saw is probably coming from their cache, and that is a massive CDN thing. So we wouldn't see any rendering time, the actual rendering time. But it does that under a second, which is not great, but it works for us. That is one consideration. It's not real-time fast. Anything else? No. Then thanks again, and that's it for today, I think.
Thank you very much. So we'll be in touch about the next one. There may actually be one in August, but it might not be here. But we'll see. We'll watch the Meetup page. If anyone wants to stay around and chat and drink beer and eat pizza, you're more than welcome. There's more beers in the fridge. Thank you very much for coming. Thanks.
Yeah. We will eventually convert it to TypeScript because like the JavaScript is really, really wordy.
Do you know if you can use
Definitely not on the server.
Yeah,
So honestly, like you have to take that Ajax logic out and do it in the store or in the dispatcher or in something listening to the dispatcher. Because on the server you just do one single render. So unless you trigger Ajax, it should be fine.
do you know if you can use so say I've got a single form, on change, can you reference a React component?
Well, that would happen on the client only, so you should be able to.